a very simplistic project. It's not that hard. It's actually like a high-speed aero problem. It's really one problem. The difference is it gives you an appreciation to when you take the fundamentals that you already know in high-speed aero and put it in a simplified application-based form, and you start to realize it's like, how do I do this again? You know the equations, you know how to solve it, but for some reason, when you put it in a practical problem, it's just not straightforward. Now, how is this relevant? You have tanks and whatnot, and you're like, okay, what am I supposed to do with tanks and propulsion systems? Well, the same exact principle. So, this, for example, what you're seeing here, yeah, tanks and all that, that's not really how a propulsion system works. You don't have any tanks attached to it or whatnot, but this is really your source of compressor, or the high pressure stream that you're having in your flow, whether it's a hypersonic vehicle in this case. So it's still regulated. You are designing hardware in an engine to regulate that pressure. So you're still in control of it, and there's bleed all around the engine. I'll show you a picture of it in a second. But in general, let's see. So right here. Okay, so it's not that clear, but I'll show some of these pictures later on. But you've got your high-speed fan right here, and compressor right here, and some of the air is actually bled right there. So that's again piece stagnation that you're controlling. It's not a tank per se, but it's a source of high stagnation pressure that you're feeding in and bleeding in throughout the engine of where you want it to be. So if you're trying to control Mach numbers down to here, or through your CD nozzle, it's actually bled from here. And that's primarily your tank source pressure. So you deal with this kind of configuration quite a bit in engines in general. But we'll tackle it once we get to advanced engines and all that. So in terms of grading for the project, they're going to be graded like the homeworks. They're not like the exam where they're heavily graded. It's going to be primarily 10 points, grade out of 10 points. If you get the final answers, you get 10. If you don't get the final answers, you get 9, but you have the equations with the steps clearly outlined, you'll get 9 out of 10. If you if you don't show the steps correctly and all that, you'll get 8 out of 10, but you still have equations. And if you don't have any equations, but you have some answers and not exactly correct, but close or whatever, you'll get 7 out of 10. Is that fair enough?
Hell yeah.
So I think everybody was over stressing about the grading. I was like, why is everybody taking it too serious? It's not that serious. I just want you to exercise the problems. This is an easy problem.
It's gotta be serious.
The solutions, yeah, I mean, I can help you.
Piece of paper.
Yeah.
Question.
So, actually, your TA already has it. So, yeah, that's pretty cool. Actually, I could upload it today. Upload the Excel sheet. This is not coding, by the way. This is all, you can do it in Excel, you can do it on your calculator if you wanted to, you can do it on a sheet of paper, and sometimes that's helpful. Which reminds me about homework 6. So, it's not coding based. There is no coding. Actually, I almost eliminated all the coding aspects in this course. So even project 2, which is ramjets, I'm not going to have you do any extensive coding. Again, it's a bunch of equations that you got to solve, and you got to solve multiple times. So whether you put it in a code form, that's for simplicity for you. But you don't have to. All you have to do is just write the equations and solve them multiple times if you wanted to. Right? So with a calculator, you don't really need to use the code-like form here. But anyway, homework 6 and homework 7, we only have up to homework 8 left. So you're almost done there. So hang in there. I know you're seniors, and the next next month is probably not the greatest part of your life, because you've got quite a bit of things due. So I understand that. But we only got homework 6, homework 7, homework 8. Homework 6 is due this week, so you only have 7 and 8. They're mostly problems like this, almost like the project. The idea is you formulate the equations like we just did in last class. The example that we've done closed out in the last class, and the example before, you'll find the homework is actually almost the same. All you're doing is just writing the equations out and then solving them. Now, if you choose to do it in Excel, MathGAD, MATLAB, Mathematica, whatever you want to do it in, Maple, all M's. So if you, anybody know Fortran?
What is that? Got phased down?
It's died. The language has died. Well, it shouldn't, but it's an engineering language, but for some reason, anyway, in terms of how you solve it, you actually solve a problem on a single condition. So let's say a specific Mach number. You're talking to that specific Mach number, you solve it on a piece of paper. Write down your equations and solve it regularly because you're used to doing that. Once you do that, then you can take your equations and just plug them into Excel, MATLAB, MathGAD, whatever you want to do, and then say, okay, vary Mach number from here to here. That's it. So it's not really coding, it's the process of how you're solving the problem. Does that make sense?
It's like a for
the homeworks? And they're pretty straightforward homeworks in general, and as we keep doing these problems, you realize they're very repetitive. It's a process. And we had a couple of questions.
Is there any way possible that we could push the homework back?
That doesn't help you. No, that doesn't help you because the exam is on the 7th. You want to start practicing the homeworks before the exam, right? Actually, here's the catch. If you realize that I'm giving you the ramjet homework right now, right? So, if I'm going to give you homework 7, it's going to be this Thursday. And it will be due when? The following Thursday, which is
midterm.
test day. So what I'm going to do is, I'm actually going to sacrifice that homework. I'm going to give you the solution at the same time that I'm giving you the homework, so that you're actually prepared for the exam, because it will be on turbofans.
Yeah, cool.
So in reality, people are smiling. You like it? Well, I'm going to be giving you the final answers. So, but it still helps you anyway because you will see the curves and everything. So all you got to do is just pretty much code it. I see your hand, but there's a few hands in the back. So you're generally okay. So if I give you homework 7, you will have a full week to solve it, but you're going to be pretty much studying for the exam as you're doing it. So I think that will actually help you better when you realize that you're going to do exceptionally well in midterm 2 because you're solving it while you know the answers, and then you're preparing for the midterm 2, which is exactly that specific. Primarily 6. No, we did 6 and 7. That's it. So 2 homeworks in midterm 2. So it's not really cumulative. So it's just focuses on those 2. If you know how to go through those 2 very well, you will do well there. Better question in the back somewhere?
Yeah, I had the same question.
Same question about? Oh, the same question. Okay, there's a column. Any questions in the back?
I just wanted to say, like, even if not to Tuesday, maybe even just Friday, because a lot of us lost our entire weekend due to the holiday. We had family obligations, and before that, this project took up a lot of time. So there's a couple exams on this Thursday as well that I think a lot of us would really hope to devote the remaining time to, and then, you know, even Friday, one day later, we could knock out your homework.
So how, okay, would Friday help everybody?
Yeah. Yeah.
Okay, so how will I get it on Friday?
I'll try them.
No.
We could drop it at
We
your office.
flood your mailbox.
I'm not coming to school Friday.
No, I'm serious because it will crash web courses. You can't handle that much uploads. PDFs and all that, it just goes crazy because some of you take pictures of the PDF maker from the cell phone and it doesn't reduce the size, and you get a significant amount of large size assignments. Even when I get it in homeworks, my email is limited to what, 15 megabytes? So right away, I don't get any emails, everything just shut down, and I don't get anything. That's the reason why we have a hard copy primarily. I'm not sure how it works for others, but for some reason our assignments are usually large size in general, and that's when it becomes an issue. So if you want to make it Friday, we just have to say you have to submit it by this time, hard copy, in front of my office. Does that make sense?
Could it be like by 5 p.m. or something? So we have Friday to work on it. When do you leave Friday? Just to get it to your office.
I'll be in the lab on Friday.
On Friday.
What if we just overlap the homework? So we give out homework on Thursday, and this one is just due. So homework 6 is due on Tuesday. Homework 7 is due next Thursday.
But I don't want to hear complaining about assignments being overlapped.
I'm gonna go out there.
Because that's what happens when it's like, oh, somebody sent me an email and said, oh, you're giving project at the same time as homework. It's like, last week we didn't have homework, right? So the project, I'm giving you extra time, in reality, to do it. Does that make sense? So, you want it following Tuesday? Yeah. All right. So make it Tuesday.
I gotta edit this
too,
video.
But
No.
keep in mind, you're the one that chose that. Don't tell me homework's overlapping.
I chose not to.
I damn the home.
Everybody's in agreement, please raise your hand, so I don't want to get emails explaining why we did this. Because for some reason, I spent a lot of time explaining things we discussed.
I was gonna email you.
Alright.
This guy gives. Oh, we did this. We burned a lot. Huh?
Let's say for actual proportions.
Started doing this, actually,
I gotta blow this.
sample problem.
Okay, we're gonna do it.
And actually, another thing is the second project. So the second project, I will give you more time, but I don't know when to assign it. It's ready, you're ready for it. But I'm trying to give you a little bit of time to assign this cycle and assign
You just assign it now and give us a month to do it?
What?
You just assign it now and give us a month to do it?
Yeah, that's what, for you it's okay. For others they say, oh, you're overlapping assignments.
Yeah, but just make it due at the end of the semester and then we have a month to work on it. It's like a week. Yeah, but give us a month instead of a week.
So project 2 was the same thing. So project 1 was the same thing. I gave it to you after spring break, and I'm giving you
I gotta edit this
so
video.
In reality, it's a 1 week thing, and we didn't have a homework, but
Yeah. So give us 4 weeks on
Who
this
sees
one.
a board of people complaining? Waste of footage.
Dude.
anyway,
Pausing like.
problems are going to be very, very similar, like with sort of a minute changes throughout, like we did with the example problem last time, where we had a ramjet situation flying at a specific Mach number and altitude, which gave us the heavy conditions, thrust, we needed thrust, specific thrust, TSFC for these conditions. I got my Tmax, this is the combustor max temperature. I got my heat input, which is primarily the fuel that I'm using, and the exit area. So, based on that, we needed to go and solve for these 3 parameters. So to get thrust, primarily we have an equation right here, and we're assuming ideally expanded, so our pressures are equal, and this is what we have as a final formulation. So we needed our velocities and the amount of mass we're ramming into that ramjet specifically. Actually, we're gearing up to fire that ramjet in the lab shortly, so hopefully we'll get to do a demonstration shortly. But my PhD student that's working on this needs a little bit of help, so to get it going. It's a 1/3 scale ramjet, so. Anyway, free stream velocity, we got it based on the Mach number. We got our mass flow rate accordingly. And using isentropic relations, we found out our static temperature, density,
velocity, and then fuel air ratio based on my stagnation temperature ratios. And from there, I substituted back into my thrust equation, specific thrust, and TSFC. This is primarily what we were after at the very end. Now, this is for one, notice that it's only for one